Alright ladies, so in this video we are going to solve systems algebraically. And the first method of algebraic solution solving is substitution. Okay, we're going to use this substitution method when it is easy to isolate one of the variables. Okay, and I'll show you what that means exactly, but let's start with our first example here. So 3x plus 4y equals 12 and 2x plus y equals 10. So here, because our y variable is by itself, right, there's no coefficient on it, it's going to be easy to isolate the y. Right? So we're going to solve for y in that second equation. And what I like to do actually is label my equations 1 and 2 just to kind of help keep track, right? So we're going to take this equation here and we're going to solve it for y, right? If we subtract 2x, we're going to get y equals negative 2x plus 10. Okay? Then what we're going to do is we're going to take this expression and we're going to substitute this expression into equation 1, right? So we're going to take and plug it in here. So this is equation 1. We're going to do 3x plus 4 times negative 2x plus 10. That's the substitution. And then we're going to go ahead and solve for x. Right? So here we're going to distribute. 3x is going to be negative 8x, so minus 8x plus 40 equals 12. Subtract the 40, so we get, well, this actually becomes what? 3x minus 8x is, sorry about that, negative 5x plus 40 equals 12. If we subtract 40, so negative 5x equals negative 28, and x equals positive 28 over 5, right? We divide by negative 5, we get positive 28 over 5. And then we're going to take this and substitute it into, actually the easiest way to do it, let's call this equation number 3. We're going to take this and substitute into equation 3. Okay? Because we've already solved for y, and this equation 3 is equivalent to equation 2, right? It's the same equation, we just rearranged it. Since we've already solved for y, we're just going to plug in our new x value into this equation to solve for y. So it's going to say, so number 3 here is going to be y equals negative 2 times 28 over 5 plus 10. So that's negative 56 over 5 plus 10. It's running out of room here, which equals negative 6/5. And so our solution then, I'll put it over here, is going to be 28 over 5 and negative 6 over 5. So you can see how this wouldn't be a good system of equations to solve by graphing, because these terms, these numbers here on a graph would be tricky to really get down just right. Okay? Alright, let's do another. Okay, here we go, number 2. Oops. We have x plus 3y equals 5, negative 2x minus 4y equals negative 5. So in this one we can see that x is easy to isolate. Right? So we're going to solve for x in equation 1. I didn't label them yet, but this is equation 1, this is equation 2. So in equation 1, we're going to rearrange it. We're going to call it equation 3. All I have to do is subtract the 3y. I'm solving for x, so I'm going to subtract 3y. So I get x equals negative 3y plus 5. And we're going to use that expression, right? We're going to substitute this expression into equation 2. All right, we're going to substitute in equation 2. So here's equation 2, negative 2 times negative 3y plus 5 minus 4y equals negative 5. Something I didn't point out in the last problem with this problem that I should point out super quick. Do not substitute this back into the first equation. It's the same equation, just rearranged, right? So if we substitute back into the first equation, then we're going to have problems. We're just going to cancel everything out, and we're not going to have any solutions. So make sure you're substituting it into the other equation, in this case, the second equation. Alright, so we're going to simplify and solve for y in this equation. It's going to be positive 6y minus 10 minus 4y equals negative 5. 6y minus 4y, that's 2y minus 10 equals negative 5. And then when I add 10, I'm going to get 2y equals 5 and divide by 2, so y equals 5 over 2. And then now we're going to substitute this into equation 3, again, because we've already solved for x here, so that makes it the easiest if we just substitute it into equation 3. So it's going to be x equals negative 3 times 5 over 2 plus 5. That's negative 15 over 2 plus 5. And so x equals, this is going to be negative 5 over 2. And so our solution is negative 5 over 2, positive 5 over 2. And again, you ladies, you really do want to check that these solutions work, right? So just check them by plugging them back into the two original equations and make sure they work, okay? Definitely make sure that you are checking. Alright, we're just going to do a couple more, and that'll be it for the day. So here's number 3. Oops. So we got x plus 6y equals 2, and 5x plus 4y equals 36. So I'm going to do this a little quicker. Here we can see we can solve for, let's number these, right? We can solve for x in this one just by subtracting 6y. So this leads us to, sorry, I want to write it with the right, x equals negative 6y plus 2. This is going to be our third equation, and we're going to use this expression and substitute it into equation 2. Alright, so it's going to be 5 times negative 6y plus 2 plus 4y equals 36. And then we're going to simplify. So this is negative 30y plus 10 plus 4y equals 36. Negative 30y plus 4y is negative 26. Y plus 10 equals 36. We subtract 10, we get negative 26. Y equals positive 26. And when we divide by negative 26, we get y equals negative 1. So then we're going to take that and we're going to substitute it into this equation up here. Again, because we've already solved for x, so make it easy on ourselves. It's negative 6 times negative 1 plus 2. Well, that's just 6 plus 2, which equals 8. So the solution set is 8, comma, negative 1. And again, do a quick check in both equations to make sure that's good. Okay? Alright, let's do one more, and then we'll be done. One more here. So we have, we'll change up the variables a little bit. R plus S equals negative 12. And 4r minus 6s equals positive 12. This is number 1 and number 2. Now in this first equation, both r and s are easy to isolate. So it doesn't really matter which one you choose. You could choose either one. I'll isolate r in this case. So to isolate r, we just subtract s, so we get negative s minus 12. Okay, so negative s minus 12 is going to be our third equation. But we're going to substitute this expression into number 2. So r equals that. So it's going to be 4 times negative s minus 12 minus 6s equals 12. And then we'll distribute. So that's negative 4s minus 48 minus 6s equals 12. Negative 4s minus 6s, that is negative 10s minus 48 equals 12. If I add 48, I get negative 10s equals 60. And so s equals negative 6. And then I'm going to take and plug that right into this equation up here. So we'll do r equals negative. Now be careful here, this is a negative 6. Those are two different negatives, right? The negative in the equation, oops, sorry about that. The negative in the equation up here is not the same negative as the negative 6. Okay, so that's why we have negative 6 minus 12. Well, that's positive 6 minus 12, which equals negative 6. And so the solution is negative 6, negative 6. Now be careful here, right? Whenever we put ordered pairs together, we put them in alphabetical order. So this is r comma s, just to be r comes before s, right? So that is solving systems of equations by substitution. And we're going to stop there for today. But the next block we meet, we're going to be talking about other ways to solve algebraically as well. So here we go with that for today. And if you have any questions, of course, let me know. Take care.